We'll proceed in pseudo calculus problems. Okay, pseudo calculus problem, the area in which we are pursuing the discussion. Pseudo calculus problem. Okay, the idea is to take problem by problem and solve it. We'll take another problem. I believe we will conclude the perimeter and area concept because the beginning things are the kind of, it is the pillar stone. On top of it, the other example would be based upon. So beginning is the area and perimeter calculation, and we are into area calculation. How we can calculate area of a circle? In a way, summation of subsections. If I divide the area of a circle into n part, and then if I add all the part, then it will become area of the circle. And then we can produce all these parts into a summation, and then how I can convert this summation into integration. This is a very big trouble to everyone. How to switch into integration? How to switch into integration? If I define a mathematical problem, if I am defining a mathematical problem, then all of a sudden, how I can switch this from this mathematical issue problem into the kind of integral calculus or differential calculus and so on. So this is a kind of, this is a concern for everyone. Anyway, we have been saying that multiplication can be converted into integration. A multiplication, if I multiply y into x, and y is function over x, I can rewrite as fx into x. Now fx into x, where one there is multiplication, and there is an operator called multiplication operator, and two operand are there. One operand is dependent upon another, means one operand, that is y, that is dependent upon x, that is x, fx into x or y into x. It has to be rewritten as y into dx, not x. That will be false. That will give error. If I say y into x, I have to find out where if y is function over x, and what is your function over x, that is sin x. So sin x into x is x sin x. That is wrong. Sin x into x is actually minus cos x. Mind blowing, amazing. Anyone would be thrilled upon. If I say y into x, what is y into x? What is your y? Y is sin x. Sin x into x is x sin x. That is completely false. If I am multiplying two items, and one item is dependent upon another item, and one item like x is independent on top of it, y is dependent upon, then sin x into x will be rewritten as sin x dx, and it will be minus cos x. So sin x into x is not x sin x, it is minus cos x. Similarly, y by x, when y is dependent upon x, then it can be rewritten as dy by dx. That is true statement, not the like, if y by x, what is your y? Sin x. Sin x by x is how much? That is sin x by x. Not true. Sin x by x is actually cos x. How you can prove like that? Okay, I have many times I have given this example, that how how it turns into a different kind of concept. How it turns into different kind of concept. Like consider two bags. This is the always I give this example. Consider two bags. One bag is orange, and one bag is tamarind. Okay. Now, when in the orange bag, when there is one orange, in tamarind bag there is one tamarind. What is y by x? 1. Per orange, there is one tamarind. Now, in orange bag, after some time, if I say this, see, there are two oranges. Then in tamarind bag, if I see there are four tamarind. What is y by x? 2. It is varying now. Now in orange bags, sometimes I see four oranges. Then I go and see the tamarind bag. Then I have 16 tamarind. What is y by x? 16 by 4. 4. It is changing. Okay. Now I understood one thing. If there is X orange in orange bag, then there is X square tamarind in the tamarind bag. What is Y by X? Y is number of tamarind in the tamarind bag, and number of orange in the orange bag is X and 1 is Y. Y by X. How much is tamarind per orange? How much is tamarind per orange? If orange is X, then tamarind is X square. Means per orange there is X. If per orange there is X tamarind, provided there is X amount of orange in orange bag, then per orange in orange bag there is X tamarind in the tamarind bag. Okay, this is how it is. Tamarind by orange means per orange in the orange bag, how many tamarind in the tamarind bag? That is X. X squared by X means if at any time there is X orange in the orange bag, then there is X square tamarind in the tamarind bag. Per orange, there is X square by X. What is per orange tamarind? Means if I add one orange in the orange bag, then I have to add how much is in the orange bag. That what I have to add. That is X square by X. Consider any moment I have now 5 oranges in orange bag. That is, I have now 5 oranges in orange bag. Now consider I am adding one more orange here. Right now I have 5 oranges, means X equal to 5. At that moment I have 25 tamarind in the tamarind bag. 5 orange, 25 tamarind, X square. Now if I add one orange here, means per orange how many I need to add in the tamarind bag? That is X square by X. So I have to add 5 orange here, 5 tamarind here. Or if it becomes 6 here, then say I am adding 6 here, whatever it is. Now right now it is 5 and it is 25. If I add 5, it becomes 30 and it becomes 6. Now it should be 36, not 30. Okay, consider any moment I have here 11 oranges. Then I have 121 tamarind in the tamarind bag. I add one more. Then I have to add X here as per X square by X. Okay, in that sense, I have to add 11 here. That will become 132. 121 plus 11, 132. Here it will become 11 to 12. It should be 144. It is 131 only. This formula is not working. That is how many tamarind per orange. Then where it will work? It will work. Consider that at any moment, now forget whatever I have said. Now consider that any moment in orange bag, I have 3 oranges. Then in tamarind bag, I have 6 tamarind. Then I have 6 oranges. 3 oranges I had, 6 here. Now I have 6 oranges, then I see here 12. I have 9 oranges here, then I see 18. Then I understood. It is 2x. If it is x, then it is 2x. Now how many tamarind per orange? 2x by x, that is 2. 2 tamarind per orange. Now any moment consider I have 11 oranges. At that moment I have 22 tamarind. If I add one more here, then I have to add 2 here as per the division. Then it will become 11 to 12 and it will become 22 to 24. Now very nice. If I have 25 orange here, then I have 50 tamarind here. 2. Now if I add one more, then I have to add 2 more. 25 to it becomes 26. 50 to it becomes 52. Exactly. 2 times. Means if numerator versus denominator is constant, 2x by x, means numerator is not dependent upon denominator, means it is constant. So in that fashion, we don't need extra intelligence, not required. It is always 2. But if numerator versus denominator is algebra, means numerator is considered as dependent upon denominator. If it is x and it is x square by x equal to x, means more or less numerator is dependent upon denominator. So x square by x, that is how many tamarind per orange, that definition itself will be changed into how many change in tamarind I see per unit change in orange. Now it will turn into calculus now, because when orange was x and tamarind was 2x, Then I anticipated. Any moment I add one orange, I can add two tamarind, and it follows the equation. But if orange has x orange and tamarind had x square tamarind, in that fashion, if I divide x square by x, that is x. Now, if any moment if I add orange and see how many oranges are there, I have to add same tamarind here as many oranges are there. It is not working. Makes sense? Both are not same. X square by x or 2x by x, both are not same. It should be same. If I see x and x square, I take one more example. Consider now that I have 20 here, then here we have 400. I add one more here, it becomes 21. Now x is 20, so I have to add x here. 200 plus 20 is 220. Here it is 21. 21 into 21, I believe it will be more than 440, where it has 220 only. Not working. What it will work? Because it will fall into differential calculus. If numerator is dependent upon denominator, vaguely I say, then it will fall into differential calculus. Y by x will be converted into dy by dx. Now, in that sense, y is the number of tamarind, that is x square, and orange is x. X square by x will be rewritten as dx square by dx. It will be 2x actually. Now, whenever I add one orange here, then I have to add 2x tamarind here. Now, if it is 200, it is 400. If I add 1 here, then it becomes 21. Now, at that moment, 20 into 2, 400 I have to add, 40 I have to add here. 440 it will become. If it is 21, then it should be 21 into 21. 21 into 1, 1, 2. We have 21 into 2, 42. 2. That is 441, I believe. It should be 441. 21 into 21. 21, 1, 1, 2, 21 into 2. That will be 42 plus 2, 44. 441. Now it is 440. More or less same way it is going on. So here this is one way of saying multiplication and division. If one is dependent upon other, then you must solve, anyone must solve it through integral calculus or differential calculus. Normal multiplication, normal division will not work. There is difference. Anyway, this is the first concept. Second concept is if I have repeated summation, then it will change into integral calculus again. Repeated summation, typically it lands up into arena of multiplication and then multiplication to integral calculus. Okay, so the concept that we are pursuing now, that what is the area of a circle. So area of a circle, we have tried to finding out the area of the circle through repeated addition. So repeated addition means if I have to find the area of the circle, this is x-axis and this is y-axis. Okay, in that fashion, I take a radius like this. Okay, I take radius like this, and radius I move like this, and then I start dividing the circle into many sections. This is one section. This is called wedge. Wedge means one side is straight line, one side is straight line, and last side is not a line rather than an arc. This is a wedge. Wedge number 1. Then wedge number 2 from here. Wedge number 2, and then wedge number 3. This one. Not from here to here. Third one. Wedge number 4. Wedge number 5. Okay. Like that, I divide this circle into so many wedges. This is the first wedge. This is second wedge. This is third wedge. Like that. In end division, if I find the area of one wedge, if I get to get the area of one wedge, if this is the wedge, let's say what is area of the ith wedge? What is the area of the ith wedge? Or what is area, whatever it is. I have divided circle into n number of wedges. What is the area of circle? Area of circle is A1, that is area of wedge number 1. A1 plus A2 plus A3 plus A4 plus A5 plus AN. Area of the circle is A1 plus A2 plus A3 plus A4 up to AN, or summation sign. that is sigma summation sine I equal to 1 to n a and super and top is called, I believe, a superscript, and this I forgot again. Okay, so capital A, that is the area of wedge number, bottom right I. I believe top is called postscript, superscript and basis. I'll refer it again. Okay, so A sign and bottom right small I, AI, summation of I equal to 1 to n AI. That is the net area of this circle. Area 1, area 2, area 3, up to area n. This is the area of this. Now question is arising, what is area of A1? What is area of A2? What is area of A3? What is area of A4? Something like that. Okay, in that fashion, let's consider the area of ith section. If this is x-axis, then this is the first area, then this is second area, third area, area of ith section. Then what we have considered area of ith section is nothing but this radius and this radius. Consider these are the two radius. From here, arc falls like this as perpendicular on this line. Arc, this is the arc of the circle. So radius may be a function of angle theta anyway. This is radius 1 of the ith section. Consider this is ith section of this area. Then this is R1, this is R2. This is the arc of the circle. This arc passes like this. Arc, and any moment the arc is tangential at this point. If this is the radius and this is the arc passing through, if I draw a perpendicular line here, then it will exactly coincide the arc line. Then arc passes like this. Here, arc will be perpendicular at this line. If I take arc that is perpendicular at this line, then more or less I can consider this angle is very small. This angle is delta theta I. What I'm saying is, if this is x-axis, then at any moment I am at angle theta, and this is the ith section and it has width of delta theta I. If it has width of delta theta I, then this arc I can consider as R1 delta theta I. Okay, now it makes a 90-degree line from this R2. So I can say the area of this is half area of a triangle, 90-degree triangle. If I take a 90-degree triangle, then this area 90-degree triangle is like this. The area of triangle is height by into length, height into width by 2, because height into width I take, it will make area of a rectangle, height into width by 2. Similarly, if I am taking the area of this ith shape, then it will be width into height, that is the R1 and delta theta, that is the arc length. Means R1 means 1 by 2 R2 into R1 delta theta I is the area of the ith section. Okay, now R1 and R2 both can be function over theta. If they are not function over theta, then they are same. If they are same, then area of ith section is 1 by 2 r square, r into r, because both radius are same. If in circle radius is not a function over theta, we have demonstrated it many times. Radius can be function over theta. Typical example is r equal to cos theta. R equal to cos theta, it also make a circle. Okay, this is a circle and it is centered at the origin. It has fixed radius. Then r is not function over theta. R would go like this. Radius of this circle will start from here and it will go like this, and everywhere it is constant. But if I talk about r equal to cos theta, it makes another circle like this, where center is here, whereas origin here 0, 0, origin is here, where center of the circle is here. This is the equation of a circle r equal to cos theta. Please watch our previous video. Anyway, and radius in this circle, radius in this circle, radius starts from 0 angle and it goes till 90-degree, and then radius starts becoming negative. We draw radius in opposite direction to make radius positive, and then we go. So this angle is pi degree, not 2 pi. If I see in Cartesian coordinate system, this angle looks like 2 pi. But if I actually see r equal to cos theta through the polar coordinate system, then angle spans only pi 180 degree, where r equal to cos theta. Theta starts from here, and when theta is 90 degree, this line converges to origin. This is origin. This point is origin. Now, after this origin, when angle goes beyond 90 degree, the radius start moving here, that is negative. We draw radius positive in opposite direction. And when angle is 180 degree, it makes full circle. Anyway, if consider radius is constant, here radius is changing. Radius, when angle is 0, radius is full diameter. But radius starts shrinking when angle is growing, r equal to cos theta. If I say now we are in phase of, if if I move the radius, one time will come where this is radius 1, and then it moves delta theta I, and this is radius 2. This is the ith wedge. If I divide the circle into n different parts, then ith part has radius r1 and radius r2. This may not be same, whatever it is. If it makes delta theta I with the center, then this is the arc. This arc will fall directly at 90. This is what we consider. Arc will fall at 90 degree on R2. This arc length will be R1 delta theta I. This will make a triangle whose area will be 1 by 2 R2 into R1 delta theta I. That is 1 by 2 R1 R2 delta theta I. If R1 and R2 are same, it will become 1 by 2 R square, or the radius is A, 1 by 2 A square, that is constant. Then delta theta I. What is the net area? Summation of I equal to 0 to n, and then 1 by 2 A square delta theta 1 plus 1 by 2 A square delta theta 2, delta theta of the second section. Like that, plus 1 by 2 A square delta theta n. I can take out 1 by 2 A square. It will become delta theta 1 plus delta theta 2 plus delta theta 3 up to delta theta n, where delta theta is angle of each section. Each wedge I have taken out the way I have cut the circle into n parts. So all delta theta, they are mutually exclusive to each other. This is the better word. I used to say independent. They are mutually exclusive to each other. There is no, there is no intersection between them. Now I can say delta theta I plus delta theta 1 plus delta theta 2 plus delta theta n is 2 pi, whatever it is. I have net area is 1 by 2 A square summation I equal to 1 to n delta theta I. This is the typical case of repeated summation or summation. This can be converted into integration, that is d theta. Delta theta I is 1 to n, can be converted into d theta. Where if we convert into d theta, we consider that n tends to infinity. Okay, in that fashion it will be converted into d theta. Integration of theta from 0 to pi, not 2 pi. Okay, I'm sorry. If r is constant, then 0 to 2 pi. Then area will be 2 pi into 1 by 2 A square, pi A square. Anyway, consider that r is function over theta. R is function over theta. In that fashion, it will become summation of I equal to n 1 by 2 r1 r2 delta theta I, where r1 is function over theta and r2 is function over theta. If I say in terms of r1, if I say r1, this is x-axis, and this is r1, this is r2. Radius is shrinking. If I say r1, then it is function over theta. Function over this theta, how much theta has a span. In that case, r2 will be function over theta plus delta theta I, whatever it is. In general term, I can say both are function over theta. In that way, area is 1 by 2, and then 1 by 2 f theta into f theta, or f theta into f theta plus delta I, into delta theta I. Okay, f theta into f theta plus delta theta I, and then into delta theta I. This is the area of the ith wedge. Okay, I can rewrite as f theta plus delta theta, considering delta theta is very small, f theta into f theta. These are approximations that I personally don't like. But this is how it is summation to convert into integral calculus. Now it becomes summation of I equal to 1 to n 1 by 2 f theta into delta theta I, 1 by 2 f theta function over theta whole square delta theta I. it will become integration 1 by 2 function over theta whole square d theta. Integration from 0 to whatever we are taking. If I take function over theta as cos theta, radius equal to cos theta, then it only spans pi. Depends upon what function we have taken. So area of a circle, that is r equal to cos theta, is integration of theta limit is 0 to pi 1 by 2 function over theta whole square d theta. It will become 1 by 2. I can keep outside cos square theta d theta. That will become like a theta by 2 plus sine 2 theta by 4. Limit 0 to pi. It will become pi by 2 and outside 1 by 2. Pi by 4 will be the area. Anyway, we were into discussion that how to verify that the ith section area we have taken 1 by 2 function over theta whole square delta theta I is perfect or not. To calculate that, we will actually calculate the area of a circle in terms of d theta. Then we will see this is called reverse or verifying it. Now, in that fashion, if we are taking it, then consider a case of a cylinder, or case of a sphere, whatever comes to mind. If I take case of a cylinder, okay, consider the case of a cylinder. Consider a case of a cylinder. Now, if I take case of a cylinder, if I talk about any point on the cylinder, this is cylinder circle, base circle, which has radius as a and angle is 2 pi and height as z. If I take any point on this cylinder, this point can be represented in the coordinate system. If I talk about cylindrical coordinates, proper cylindrical coordinate system, then point can be it can be represented. A point can be noted through r comma r theta comma z. R is the radius. What is the point? Any point on the cylinder. This is the radius. Okay. I am talking about any point on the cylinder. Cylinder has three coordinate system. One is height, one is base. In base, we have radius and angle theta. If I take any point here, then it is the radius from the center, that is one coordinate. Theta I cannot take because theta is angle. I have to take in length only. R theta, the way we demonstrated now, if I have radius and if I have angle, then arc length will be r theta. In that fashion, the other coordinate of this cylindrical coordinate system will be r theta. R theta represents the theta. So any point P here, I can say r comma r theta comma z. This is point P. Okay, if this is point P, I can cut this point P into z theta plane. I can cut this point P into zr plane. Makes sense? Okay, there are three planes now. There are two planes now. There are three axes now. One is called theta axis. One is called r axis. One is called z axis. These are the three orthogonal components in cylindrical coordinate system. R, theta, and height, that is z axis. Theta axis, r axis, and z axis. Theta, theta only lies on the base plane, r theta plane. I'm sorry, radius. Not like a sphere where radius goes all along. If I take a sphere, okay, if I take a sphere, then if I take the center of the sphere, then radius goes all in 3D direction. Everywhere radius goes. But if I take cylindrical coordinate system, radius is only in 2D shape and angle is also in 2D shape. Height is there. In that fashion, radius will start at the center and it will go along on the xy plane, if I can say. And theta will move 2 pi degree in the base only. Okay, z will go up. Now we have any point P here, P here. If I cut P in z theta plane, consider there is a hypothetical plane called z theta plane. If I cut, then there will be an arc. Like consider this is x axis and this is y axis and this is z axis. I have a 3D shape. I take any point P here. I can cut in zx plane. Makes sense. Like I take a 3D shape. Consider I take a sphere. Though it is not a sphere, but consider this is a sphere. Consider this is a sphere. consider this is a consider this is a sphere. If this is a sphere, then this is xy plane, this is x axis, this is y axis, and this is z axis. Now at this point in x comma y comma z, this is, I kept it on xy plane, just consider. Or I make it centered at the origin. If I say this is centered at, if I say this is centered at the origin, then center of this sphere is inside it, that coincide the origin, that is 0 comma 0 comma 0. From there I draw a line to any point p here, that is x comma y comma z. If I have to cut in xz plane, I'll cut like this. If I have to cut in yz plane, I'll cut like this. If I cut in xz plane, it will make an arc, circular arc. If I cut this point P in yz plane, it will make another circular arc. Okay, now I have two arcs. One arc is in xz plane, one arc is in yz plane. If I talk about xz plane, then everywhere y is constant. If I take yz plane, everywhere x is constant. Okay, and then I have point P. Okay, it is similar to, if I have like this point P, this is xz plane, I cut it. At point P, I cut in yz plane. Now here, if I take this line and if I represent this line as a vector, and then here, if I represent this line as a vector, then at point P, if I do cross product of these two lines who are in orthogonal plane, I get area vector. Area vector. Similarly, if I have a point on cylinder as P and I cut it in Z theta plane, I cut it in ZR plane, I'll get 2R. And at point P, if I do cross product of these 2 points, I'll get the area vector, where in Z theta plane R is constant. This explanation is not available in any of the book. Anyone can try. Now Z in ZR plane theta is constant. Z theta plane R is constant. Now if I cut like this, then I'll get the vector representation of these two lines, the cut line. Okay, if I take the vector representation of these two lines and I do cross product, then I'll get the area vector. Okay, this is what we will try to get it. I'll get the area vector. Okay, if I cut the z, what is this point P is? P is theta comma theta r comma z, or I'm sorry, r comma theta r comma z. R is represent the radius, theta r represent theta, and z represent z. Now, if I talk in vector, then it is r unit vector plus r theta unit vector plus z k unit vector. Now, if this is the vector, then what is the vector representation of a cut I make in z theta plane, where r is constant? To get that, whatever vector we represented, I have to take out theta from here. If I take out theta, this, please watch our previous video. This is typically called length vector. Length vector is a vector where we represent the component of the vector in division. So if I take out theta here, it becomes dr by d theta. If it is r unit vector plus r theta unit vector plus z k unit vector. If I take out theta here, then it will become r by theta r unit vector plus r is constant. So r into theta, r is constant here. So r theta by theta, r theta unit vector plus z by theta k unit vector. Now division will change into differentiation the way we have described. Now it becomes, and multiplication will change into integration. Now we have r by theta r unit vector plus r theta unit vector plus z by theta k unit vector, bracket close, into theta. Into theta will become into d theta because it is multiplication, and division will become differentiation. Now r by theta will become dr by d theta. R is a function of theta. I am not making it 0. dr by d theta r unit vector. I'm sorry, I'm really sorry. Here r is constant. This is what I said at the beginning. If I cut in z theta plane, r will be constant. This is when I take out theta as the theta. and make it, then theta is variable. That's why theta is divided everywhere. dr by d theta. Per unit change in theta, how much r is changing? Not changing. It is constant, 0. Plus r theta unit vector plus dz by d theta, dz by d theta k. Now consider that P point is on top side, not here and there, only on the top circle. Actually, we are trying to get the area of this top circle. That is same as bottom circle. Consider this point is on top circle where z is constant. In that fashion, dz by d theta will again be 0. It will come as r theta unit vector into d theta, r theta unit vector d theta, cross product with another vector. Another vector is again r unit vector plus r theta theta unit vector plus z k unit vector. From there I have to take out r because this corresponds to zr plane where theta is constant. If I take out r, it becomes r by r, means r unit vector plus r theta by r theta unit vector plus z by r k unit vector, bracket close into r into dr, where r and theta are independent of each other. Anyway, if I talk top side, then r and z is constant. Then in that fashion, it will become r unit. It will become r by r means r unit vector plus r theta by r, d theta by dr 0, dz by dr 0, r unit vector. Here we have r unit. Here we have r theta unit vector cross product with r unit vector. That will become that that r theta unit vector cross product r unit vector. That will become r k unit vector. So area vector of the top side is r into k unit vector d theta dr. Now to get this area, we have to calculate its magnitude r dr d theta, r dr d theta. Okay, if I take r and theta both as varying, r and theta both as varying, then the area of eighth section, mind it, we are trying to calculate area of a circle by computing the area of each section, where each section of the circle I have divided into n parts. Ith section we are trying to calculate area. If ith section I am trying to calculate the area, in integration it is coming like r dr d theta. More or less I can rewrite as r is function over theta. If I take function over theta, f theta or r as a function of theta, dr r of the ith section, dr r is function over theta. Right now consider I am taking r as variable and theta as variable. R is varying, theta is varying. Then it will become r dr d theta or ri dri d theta I. I'm sorry, I'll rephrase this. It will become r delta ri delta theta I. This is how we transfer back into the integral calculus to the summation. It does not look elegant. We will change r into theta. How we can change r into theta is r dr d theta, integration of r and theta. R dr integration is r square by 2. Now it changed into integration over theta, r square by 2 d theta. R square by 2 d theta, if I say, and if this integration I transform into summation, then r square by 2 d theta will change into r is a function of theta. F theta whole square by 2 d theta will convert it into delta theta I. Integration sign will convert it into summation of I equal to n. What is integration sign is, if I take case of our circle r equal to cos theta, then angle is 0 to pi. The angle that is 0 to pi, I break into n parts. This is what we are doing. If I break it to n parts, then it can be rewritten as summation of I equal to 1 to n. Summation I equal to 1 to n. Okay, one thing. And next thing can be written as 1 by 2 r square, function over theta whole square. D theta will be converted at delta theta I. This is the area of the ith section. Ith section area is 1 by 2 f theta whole square delta theta I. Addition of all sections will give the area. I equal to 1 to n, 1 by 2 function over theta, that is r, whole square delta theta I. where it is divided into I equal to 1 to n, where theta angle goes to 0 to pi in case of our example r equal to cos theta. If I take another example where theta goes from 0 to 3 pi by 2 and it makes a circle, then, then we have divided into n part where angle goes from 0 to 3 pi by 2. Depends upon the example to example. Right now, angle is 0 to pi. So, integration 0 to pi 1 by 2 r square or function over theta whole square d theta is converted into summation I equal to 1 to n, I equal to 1 to n, and then there 1 by 2 function over theta or r square delta theta I. Make sense? This is the actual summation. This is what we brought through considering it is a triangle. At the beginning, when we took the ith section, from in a lame manner, we said that the area of the ith section is 1 by 2 r square delta theta I. Through integration in perfect way, we brought in the indeed the section area of the ith section is 1 by 2 r square delta theta I, because integration came as integration 1 by 2 integration r d theta that transform into 1 by 2 r square d theta, integration sign 0 to pi, that can in summation sign that can be claimed as a ith section, then it will be 1 by 2 r square of function over theta whole square delta theta I. Okay, someone can proceed upon. We will work one more session and then we will see area little more and then perimeter, and we'll close this example. We will take an example in the statistics, and that is much awaited. If I break a stick into two parts and I take the longer part, then take another stick of the same length. I have a stick of one length, so many. I take one stick and randomly I break at some location and take the longer part and throw it. They take another stick of the unit length, break it in a random manner, take the longer part and throw it. Now collect all the longer part section and then average it and see what is the mean of the length of the longer part. So that we will take upon. This way what we are proving it, repeated summation into integral calculus, these are not available in any of them. Anyway, please do not mind supporting us. +91 the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.